Have you guys seen something like this before? You have these websites online telling you about why you should buy some piece of software, and inevitably you'll find this thing called a feature table. Often, the software that owns the site will have a column for themselves, and then they'll list a few of their competitors. And of course, they have all the features, and their competitors inevitably do not have all the features. Okay. I'm really tired of seeing charts like this because, after all, this software company published this chart and they're going to choose features that make them look good. Right? What are they not telling you? So I find that feature comparison charts are typically very bad methods of evaluating one software against others. When we say, hold on, wait a second, why don't I make my own feature comparison chart? Why don't I research each of these and then compare, all the top 5 BI tools myself, right? I can do this. Well, even if you could make the best feature comparison chart, I still don't think this is a great way to figure out if a tool like a BI tool will work out for you. Because a lot of times when you're trying to buy software, you're not actually trying to buy the software that's the best. You're trying to buy something that works for your infrastructure. Think about this like cars. Let's say that the best car is a Ferrari, right? The Ferrari is not a right choice for everybody. Where are you going to park that Ferrari? Do you live in a city where there is a racetrack or a highway where you can drive that Ferrari? The infrastructure and the needs, as well as the budget of your company, have a lot more to do with buying the right technology than finding one with the most features. Like, do you even need this feature? Do you even know what feature 3 and 4 really mean? Right? So, let's not look at this anymore. Today, I'm going to teach you a different technique that can help you evaluate all the data tech that you buy. It'll help you understand technology in a whole new level and give you a set of questions that you can ask when you evaluate new purchases. Okay? And this framework is called the data stack. We're all pretty familiar with the web stack, right? The web stack is a set of technology types that allows you to run a website. The most common one is the LAMP stack. And what this really is an operating system, a web server, a database, and then some back-end logic, right? LAMP is just one of the ways that you can choose specific technology that meets your web stack components, 1, 2, 3, 4. Operating system, web service, database, and backend logic. There are many implementations of technologies that are operating systems, web servers, databases, and backend logic, right? Some common ones no longer use PHP, that's what the P stands for, anymore, right? But for a website to work, you really need a combination of technologies that covers all 4 of these components. For data, there's a similar stack. Okay. And what we're going to do is talk about what each of these components represent, and then when you're out there assembling technology to make your data center work, you can figure out if the thing that you're buying covers 2 of these, 1 of these, all 5 of these, and how well it does its job and how well it fits with other components that are in your stack. Okay? So, the very first thing that your whole data stack has to be able to do is ingest data. Okay? If you don't have ingestion, you don't have a data center. The next thing that your data center has to do is it must have components that facilitate storage. Okay? You take in the data, you got to put it somewhere. The next thing is processing. Once you have the data, you need to be able to transform it, merge it, clean it, reshape it, label it, whatever you need to do. Okay? The next step is access. Now that you have all this data, that has been processed to fit specific needs, you need to give your users access. And if your humans are using your data, if your users are human beings, you need some sort of present. You need some sort of presentation layer. Often you can think of this as a visualization layer. Now, if the only users of data in your company are machines, you can kind of pick a data stack that has very little presentation or visualization capacity. But most of the time, we're preparing data for a combination of human and machine consumers. So I really want to call this out because this has something directly to do with BI tools, our example from before. Okay, so when you are trying to buy a BI tool, what you're really doing is trying to buy one component of your data stack that really specializes in visualization and presentation. A lot of BI tools, features, tell you how proficient this BI tool is at presentation. Some BI tools understand that for them to work, they have to acknowledge the rest of the stack. So those BI tools will tell you, well, my BI tool has, I can access data in my SQL databases, Postgres databases, right? It'll list some access options that this BI tool supports. Okay. Some other BI tools might even have some limited processing capabilities, like you can do some data modeling or some transformations using my BI tool. Now, when you look at this feature list, you should begin to ask yourself, are the features that they're espousing presentation features, access features, processing features, and how far back in the stack does it go? I do not think anyone should try to buy one piece of technology that somehow reaches 100% proficiency in all 5 of these stack components. Instead, what most likely happens is you have a BI tool that specializes in presentation and perhaps a database like Postgres that specializes in storage, right? Postgres's top capability is storage. That's the primary role it serves in a data ecosystem. But Postgres is also not shy about doing some transformations, maybe using things like dbt or stored procedures and views, right? So this is what Postgres can do. And Postgres is pretty darn good at giving you access to the data within, right? You can connect to this via a URL, you can connect to this via any SQL client. That's very, very common. So the combination of a BI tool that has this stack signature, maybe 80% visualization, 20% access, 10% processing, combined with a database that has this stack signature, 100% storage, 50% processing capabilities, 25% access, gives you a pretty functional infrastructure. Okay? So 2 tools allows you to cover most of your needs in these 4 components. Well, what's missing? Ingestion. Often, people forget that in order for the whole stack to work, you need some sort of representation in each of these stack components. So, for ingestion, a lot of companies that have invested in a BI tool and invested in a database, you know what they do for ingestion? It might be some like legacy scripts that some engineer wrote like a decade ago, and it's still running in their data center somewhere, bringing in flat files, financial data, application data into their Postgres. So this is some script somewhere, and it doesn't have the best ingestion capabilities, but it's the only ingestion capabilities they have, right? So this is a very common stack if you're working with a company that's 10 years or older, because They were one of the earlier data companies. Well, they probably weren't a data company. They're some sort of logistics or automation or operations outsourcing company. They have some amount of tech, and they've really not thought about their data stack for a long time. And if you look at all your technology that's making your back end work, you'll find that perhaps you've got a great database. Perhaps you've even bought top of the line BI tools. But because your ingestion is poor, it's just some script running somewhere, you aren't able to achieve a well-functioning stack. This is like a pipeline. If any component in your stack is severely limited, your whole stack is limited. Okay? So, this is what a data stack is. This is how each technology has its own stack signature, and when you stack all the stack signatures together, you get a sense of what your whole data ecosystem is capable of. Okay? So, some top questions to ask when you're evaluating technology, right? The first thing you want to do is really determine your current stack, pre-existing stack. This is not listing out all the software you have, not at all. It's figuring out what are the technologies that are grouped under data infrastructure and what is their stack signature. Sometimes one piece of technology can do multiple things. You want to categorize and catalog things that way. 2, you want to determine your gaps. You're about to go buy some technology. Why? It better serve some need. The need is, in this situation, well, for us to meet all of our ingestion needs, our whole stack doesn't have enough capabilities to do so. I'm specifically going out to find some other technology that can supplement this. Maybe this new technology, new tech, has some feature set. Feature 1, feature 2. Has some feature set that this one doesn't. Okay? You do not want to compare this tech to its competitors. Okay? That's not important. Not comparing this to its competitors. You want to compare this tech's features to the features you need to get your whole stack to work. Okay? So this is what I mean by determining your gaps. What features am I missing for my own data needs? Okay? Then you go out there and you start evaluating options. I really want to call out that paid options are not your only options. Software that has a lot of VC money behind it, they will put a lot of marketing dollars in to make sure that their solutions are top of mind. But, you know, there are so many open source solutions that are amazing. Because they're open source, they don't really pay for marketing. And yet, almost all databases in the world are open source. And people use them. People use them in every single data stack. So this tells you something. A class of technology that spends no marketing dollars is widely adopted and integrated into data stacks. You should really pay attention to open source, okay? Because databases are not the only open source tools out there. There are open source ingestion techniques, there are open source visualization techniques, there are open source processing techniques, okay? So really pay attention to this. Once you know what you're looking for, instead of looking for a software name, which will inevitably send you down the expensive, paid option, heavily marketed track, you start using different terms. Open source processing solutions instead of SSIS, for example. Okay? So here, when you Google search, you'll be searching for software names. You'll be brought into a world where a lot of marketing dollars will be thrown at your eyeballs. But if you search with the stack component, you can search like this. Open source data visualization, processing, storage or database, right? Repeat the open source. A whole new world of technology options become available to you. Okay. I'll make this very clear. All the LAMP stack technology is open source. All those websites that you see in the world are built off of open source technologies. Okay, so at this point, you have your top three, okay? You have the ability to determine what you have, to really know what you have. You have the ability to determine what you need, expressed in terms of features that complete your stack. And then you have your ability to not just evaluate, but generate more options, including open source options, which you never would find if you're searching for software by name. And if your way to evaluate software is this, all you have are the names. And these are all closed source. All right, that's it. Thank you.